Hey guys, welcome to 2015 level 2 calculus walkthrough. Okay, so basically this video I'm going to be walking through the 2015 NCEA level 2 calculus exam. Okay, let's get straight into it. Question 1. A function f is given by f of x equals to x to the power 4 plus 2x squared minus 5. Find the gradient of the graph of the function at the point where x equals to negative 1. The first thing we've got to do in this question, we're going to differentiate to find our derivative. And if we differentiate to find derivative, will give us a gradient function. And if we give our gradient function, we can find our gradient at the point. Okay, we'll say that f dash of x, okay, so f dash of x equals 2. Okay, so differentiate is the number multiplied by the power, take the power down by 1. Okay, so 4x cubed plus 4x, okay, and the minus 5 is just disappears. Okay, so at the point where x equals to negative 1, so substitute x equals to negative 1 to find our gradient. So say f dash of negative 1 equals to 4 negative 1 cubed plus negative 4. Okay, so f dash of negative 1 equals to negative 1 cubed is negative 1, so negative 1 times 4 is negative 4. Negative 4 minus 4, and that equals to negative 8. And negative 8 should be our correct answer for our gradient, okay? So just say our final answer is gradient equals to 8 here, and that'll get you your achieved grade here. Okay? So, sorry about the background noises, just ignore that, okay? So, B, f of x equals to 8 plus 3x plus x squared minus x cubed divided by 3. For what values of x is f a decreasing function? Justify your answer. You must show your use of calculus, okay? So basically, in order to be a decreasing function, so the function is going decreasing, that means the gradient must be less than 1, okay? That means it's getting smaller and smaller, so therefore, the gradient must be less than 1, okay? So first thing we're going to do is we're going to find a gradient function, okay? So that's, once again, we're going to find our derivative. So f dash of x, okay, that equals to 8 is gone, so that becomes 3 plus 2x minus, we'll just rewrite this as 1/3, so this becomes 1 minus 1/3 x cubed, so that becomes minus x squared. Yep, that becomes minus x squared, okay? And this whole thing, it's less than 0, okay? So we're going to say 3 plus 2x minus x squared is less than 0, okay? Because the gradient must be less than 0 in order for it to be a decreasing function. Okay, so now we're just going to factorize, okay? So if we factorize here, we'll have actually, I'm just gonna get a graphics calculator out. So if we plug into our calculator, that makes life a lot easier. So just put a equals to negative 1, b equals to 2, and c equals to 3 in your calculator, and you should get your answer here. So negative x squared. Okay, so you should be getting your answer as x equals to negative 1 or x equals to 3. Okay, but remember that it's less than 0, so this is not our final answer, okay? Because it's less than 0, okay, this is a positive parabola shape here. So this is the positive parabola shape, so it looks something like this. Okay, so when this parabola less than 0, as you can, well, it's not really good shape, so it should look something like this, more like this. Okay, so a parabola, okay, it's less than 0 when it's so this is our negative 1 here, and this is our 3 here. So it's less than so y is less than 0 when x is more than 3 or less than negative 1. Okay, so we're gonna say x is less than negative 1 or x is more than 3. Okay. Okay, so therefore, yeah, that should get you your justify our answer. Okay, so basically g negative q. Yeah, so getting up to here, that should get you your excellence grade here. To get a merit grade, okay, to getting the get a merit grade, regions identified or x. No, just to get an achieved grade, you're looking at finding the derivative, so equate it to 0 and solve for x equals to, so getting up to here, I should achieve here. Okay, right, moving on. Calculate the rate at which the volume of a cube is changing with respect to its length at the instant where the length of each edge of the cube is 5 centimeters, okay? So you know to calculate the volume of the cube, so let's say once the length of the side of the cube is x, okay? So to calculate the volume of a cube, that's width times width times width, so that just becomes x cubed, okay? So we're gonna say volume equals to x cubed. Okay, so calculate at the rate at which the volume of the cube is changing with respect to its length at the instant when the length of each side of the cube is 5 centimeters. Okay, so basically, first we're gonna be differentiate to find our gradient function. Okay, so v dash of x equals to 3x squared. What is the rate of change of volume when the length of the cube is 5? So when x equals to 5, how fast is the volume changing? So we're going to say v dash of 5 equals to 5 squared, and that equals to 75 centimeter cubed per centimeter. So basically it gains 75 volume for each centimeter it increases by. That's basically it. And getting up to here, that gets you a merit grade here. To get an achieved grade, okay, you're finding the derivative. So v dash of x equals to 3x squared, that gets you an achieved. Alright. A train passes a signal at a velocity of 40 meters per second. The train's acceleration, a meters per second, t seconds after it passes the signal, can be modeled by the function acceleration time equals to 16 minus 2t. What is the greatest speed attained by the train after it passes the signal? Okay, so basically, if we're trying to find the greatest speed, okay, so if we integrate this, okay, so once again we have our AVD, so acceleration integrates, you'll get velocity. If you integrate velocity, it will get you distance, okay? And vice versa. So if you differentiate distance, you'll get velocity, and if you differentiate velocity, you'll get acceleration, okay? So basically, right here, a train passes a signal at a velocity of 40 meters per second, okay? So we're going to say v of t equals to 16t minus 2t squared divided by 2 plus c, okay? So v of t equals to 16t minus t squared plus c, okay? But since the train passes a signal at a velocity of 40 meters per second, so t seconds after it passes a signal. So when the train is at the signal, it has a speed of 40 meters per second. So when we started timing, it has a speed of 40 meters per second, which means that the initial velocity is 40 meters per second. So we can say that c equals to 40. Okay? So we can say v of t equals to 16t minus t squared plus 40. We're going to find the greatest speed attained by the train after it passes a signal. So we're going to find our gradient function for the velocity. So we're going to say v dash of t equals to 16 minus 2t. Okay, that's just our acceleration basically. So now we're going to substitute the gradient equals to 0 because we're trying to find the greatest speed. Okay, so we're going to say that only happens at the turning point. So we're going to say that the gradient equals to 0. So 0 equals to 16 minus 2t. Therefore, t equals to 8. T equals to 8, but we're not quite done, okay, because we're trying to find what is the greatest speed attained by the train, okay, so therefore we have to substitute t equals to 8 back into our velocity formula, okay, so we're going to say v of 8 equals to 16 times 8 minus 8 squared plus 40, and all we need to do is plug it into our calculator, and let me just do this real quick. Sorry about that, just give me some. 16 times 8 minus 64 plus 40, that gives me 104 meters per second here. Okay, so the greatest speed attained by the train, okay, is 104 meters per second. And getting 104 meters per second right here, that'll get you a merit grade. To get your achieved grade, you're looking at solving for t equals to 8 seconds. Boom. T equals to 8 seconds, that'll get you an achieved. Right, next question. How far past the signal does the train travel before it stops? Okay, so we're going to go back to our integration. Okay, so acceleration integrates and it becomes velocity. If you integrate velocity, it's going to become distance. Okay, so we have our formula for our velocity right now. Okay, so what do we have to do to our velocity in order to make it a distance formula? So yes, we have to integrate it again. Okay, so we're going to integrate our v of t formula and we're going to get d of t. Okay, but in maths it's usually called s of t. Okay, so we're going to write it as s of t. S is basically the distance. Okay, so s of t equals to 16t squared divided by 2 plus t cubed divided by 3. Oh, not plus, it's minus. Minus t cubed divided by 3 plus 40t plus c. Okay, so we just simplify this real quick. So we say s of t equals to, so s of t equals to at squared minus a third of t squared plus 40t plus c. Okay, so I have to read the question really carefully. Okay, how far past the signal does the train travel before it stops? So basically, we start measuring the distance from the signal. Okay, and the time also starts from the signal. Okay, so basically, when t equals to 0, our distance was equal to 0. Therefore, we can say that our c equals to 0 as well. So we can say that our s of t equals to at squared minus 1/3 of t squared plus 40t. Okay, so we're not quite done yet. Okay, we need to see how far past the signal does the train travel before it stops. So when it says stops, that means the velocity equals to 0. So we're going to find out how much time does it take for the train's velocity to become to 0. And we have our v of t formula, so we're going to substitute our velocity equals to 0. And we're going to see what is our t value for when the velocity equals to 0. Okay, so as we can see, our v of t formula is here. We'll just put v of t equals to 0. So say 0 equals to 16t minus t squared plus 40. Just once again do some quick calculator work here. So t squared, negative t squared, sorry, negative t squared plus 16t plus 40 equals to 0. Okay, so we should be getting our answer as, sorry, just hold up. So we should get our answer as t equals to 8 minus 2 times of square root of 26, or t equals to 8 plus 2 square root of 26. So as you can see, this answer is negative, so it can't be possible. So our t must be 8 plus 2 times of square root of 6, square root of 26. Okay, so we just plug this to find numerical value. That should give you the time equals to 18.2 seconds. So just simplifying this, okay, that should get you 18.2 seconds. Okay, so basically now we have our time. Okay, we just substitute into the distance formula and we should get our distance of the train traveled. Okay, so I'm going to say s of 18.2 equals to 18.2 squared minus a third of 18.2 cubed plus 40 times 18.2, and if you plug this into your calculator, so 18.2 squared times 8 minus 1/3 of 18.2 cubed plus 40 times 18.2. That should give you your distance as 1,368.4 meters. Okay, so it should give you your distance as 1,368.4 meters here. And getting your correct distance here, okay, getting the correct distance here will get you your excellence grade. Okay, to get a merit grade, you have to find when is v0. Okay, so you find your 18.2 seconds here. And you found your equation for distance. Okay, so if you find your 18.2, that's one aspect here, and you find your s of t, which is here, that gets you, that's point number 2. So both of these points, that'll get you a merit grade. To get an achieved grade, you're looking at finding the correct time, which is 18.2 seconds, or finding the correct formula for distance. Okay, so either one of these two will get you an achieved. Okay, both for merit, one for achieved. All right. Moving on. Okay, question 2. The gradient function of f is given by f dash of x equals to 4x minus 3. The point 4, 6 lies on the graph of the function. Find the equation of the function f. So, okay, as you can see, we're given the gradient function and we're trying to find the function. So basically, we need to integrate in order to find our function, okay? So basically, we can say f of x equals to 4x squared divided by 2 minus 3x plus c. So if we simplify this, f of x equals to 2x squared minus 3x plus c. Okay, we have our point 4, 6 lies on the graph. So we're going to substitute x equals to 4 and y equals to 6. So 6 equals to 2, 4 squared minus 12 plus c. So if we plug this to our calculator, we should get that our c value should be negative 14. Alright, we should get c equals to negative 14. So therefore, we should rewrite our function as f of x equals to 2x squared minus 3x minus 14. Not 3x squared, 2x squared, okay? And that will get you your achieved grade here. Okay, a function g is given by g of x equals to x squared minus 3x plus 18. Find the equation of the tangent at the point of the graph of g when the gradient is 0. Okay, so the gradient is 0, okay, that means it's a turning point, okay? So first thing, we've got to differentiate to find our gradient function, okay? So g of x equals to 2x minus 3. So the graph of the g where the gradient is 0. So what x value is the gradient equals to 0? Okay, so we can substitute our gradient equals to 0. So 0 equals to 2x minus 3. Okay, as you can see, x here equals to 1.5. Now that we have our x value, all we need is a y value, okay? So in order to get our y value, we substitute x equals to 1.5 into our g of x here. So we're going to say g of 1.5 equals to 1.5 squared minus 4.5 plus 18. Yeah, if we plug it into our calculator, we should get that our y value should be equal to 15.57. So therefore, we're going to rewrite our equations. Our tangent equation is y equals to mx plus c. The gradient is 0, so y equals to c. C, as you can see here, is 15.75. So simply going to say y equals to 15.75, and that there will get you your merit grade here. To get an achieved grade, you're finding your x equals to 1.5. That here gets you an achieved. Alright. In relation to the graph, fully describe the point when this tangent meets the function. Okay. So basically, if we find our g double dash of x, okay, so we're doing our second derivative text. So g dash double dash of x equals to 2. This is positive, therefore this is a minimum. Okay. So simply we're going to say our tangent meets the graph at a minimum. At a minimum turning point. And making this correct statement, that simply will just get you an achieved. Okay, moving on. A skateboard park has a mound that is h meters high at the point with the horizontal distance from a fixed point P is x meters. The mound can be modeled by h equals to negative 0.5 x squared plus 3x minus 1.5. What is the maximum height of the mound? So simply here we're going to be differentiating to find our gradient function, okay? So h of x, h dash of x, h dash of x equals to negative x, equals to negative x plus 3, okay? So we're going to substitute our gradient equals to 0 to find our maximum turning point. So 0 equals to negative x plus 3. So simply our x must be equal to 3. Okay? So, but it asks you for the maximum height of the mound. So now you have that way, when x equals to 3, you have your maximum height. So now we substitute x equals to 3 in order to find what what our height is at x equals to 3. So we're going to say h of 3 equals to negative 0.5, 9, 3 squared is 9, plus 9 minus 1.5. Alright, so that should give you your height should be 3. Okay, so your maximum height should be 3 meters. To find your maximum height here, that will get you a merit grade. To get and achieve, you're finding the correct derivative and to find x equals to 3. So finding x equals to 3 here will get you an achieved. Alright, moving along. A ramp up the side of the mound is a tangent to a mound. The ramp can be modeled by the function h equals 0.5x minus c. Use calculus to find the vertical distance below the top of the mound where the ramp will meet the mound. Ignore the thickness of the ramp. Okay, so as you can see, we have our tangent to the mound, okay, and we have our equation for our tangent, okay, h equals to 0.5x minus c. As you can see, they give you 0.5x, meaning that our gradient equals 0.5. So basically, what we have to do now, okay, we're going to find the vertical distance, okay. So basically, the first thing we're going to do is, what is our x value when the gradient is 0.5? And the only thing we got to do is we got to differentiate to find our gradient function as we done up here before. Okay, so we're going to say our h dash of x, that equals to negative x plus 3. Okay, our gradient equals to 0.5, so 0.5 equals to negative x plus 3. Negative 2.5, yeah, negative 2.5 equals to negative x. X therefore equals to 2.5. Okay, so now we simply substitute our 2.5 into our equation to find our height, okay? So basically h of 2.5 equals to negative 0.5, 2.5 squared. Was it plus? No, it was, yeah, it was plus 7.5 minus 1.5. So 2.5 squared divided by 2 plus 7.5 minus 1.5. That should give you your sorry. Wait, sorry. Sorry, that should give you your answer as sorry, a bit sick recently, so sorry about that. No, sorry, I'm doing this wrong. So 2.5 squared divided by 0.5. Oh, sorry. Times 0.5 plus 7.5 minus 1.5. That gives you a height as 2.875 meters. Okay. Okay, so we're not quite done. Okay, use calculus to find the vertical distance below the top of the mound, where the ramp will meet the mound. Okay. So basically, so you should wait, hold up. Sorry. Wait, sorry, hold up here. So, so when x equals to 2.5, the height of the mound is 2.875 meters. Yeah. So we have our height equals to 0.5x minus c. We substitute our height equals to 2.875 equals to 0.5, 2.5 minus c. Let me see what this will give us. This should give us minus 1. That should give you your C value. C value should come out as 1.625 meters, okay? And what am I missing here? Sorry guys, just hold up for a second. I apologize. I should have been more prepared. We got C equals to 1.625 meters, and if we go back to our equation, so vertical distance below the top of the mound. Oh, below the top of the mound. Oh, sorry guys. I understand what that question is asking us now. Okay, so we found our height equals to 2.875 meters, okay? We found that our highest point on our the highest point in our mound is 3 meters. So therefore the difference to find the vertical distance between below the top of the mound. So basically we have our vertical distance we found is 2.875 meters, and the very highest top of the mound is 3 meters. So therefore the difference between them should be 3 minus 2.875 meters. Therefore this should give you 0.125 meters. Right, that should be your final answer here at 0.225 meters here. That'll get you an excellent. Yeah, sorry about that. I got a bit confused with the wording, so that's my bad. Apologize. So that'll give you your answer at 0.125 meters. To get a merit grade, you're finding your 2.875 meters here. That'll get you a merit. To get an achieved, you're looking at x equals to 2.5. Alright, apologize again for holding up for so long. Just it took me so long to understand what the question was asking. Alright, sorry, moving on. The height, h meters, of a skateboard path at a horizontal distance, r meters, from another point, q, can be modeled by the function h equals to r cubed divided by 3 minus 2r squared plus 3. There is a height regulation that requires no part of the skateboard path to be more than 3 meters above the ground. Fully describe this curve, including the turning points, and state whether or not the skateboard complies with the height regulation. So once again, okay, we've got to differentiate to find our gradient function, substitute the gradient equals to 0 to find our turning points. So basically, h equals to 1/3 of r squared minus 2r squared plus 3r. H dash of x equals to r squared minus 4r plus 3. And if we say this equals to 0, gradient equals to 0, so therefore 0 equals to r minus 3, r minus 1. So therefore, our r values are r equals to 3 and r equals to 1. We got to do our second derivative test to see which one is a maximum turning point and which one is a minimum turning point. Okay, our second derivative, sorry. So h double dash of x equals to 2r minus 4. H double dash of 3, and that should give us, h double dash of 3 gives us 2. This is positive, therefore this is the minimum. Okay, we have h double dash of 1. That gives us negative 2. This is negative. Therefore, this is the maximum. Okay? So, because it says that the highest point of the skate path cannot be more than 3 meters above the ground. Okay? So, basically, we're going to be checking our maximum. Okay? So, if we check our maximum, whether our maximum is above 3 meters or not. Okay? So, I'm going to substitute h equals to 1 back into our original equation. So, h of 1 equals to... equals to 1 divided by 3 minus 2 plus 3. That should give you, so 1 divided by 3 minus 2 plus 3. Okay, this only gives us 1, and so this only gives us 4 over 3 meters. Okay, this is less than 3 meters. Therefore, it passes the regulation. So we're gonna say this passes the regulation. Okay. we're not going to check our minimum because we know our minimum must be at a lower point than the maximum. So if our maximum is already lower than 3 meters, we know that our minimum will definitely also be lower than 3 meters because the minimum cannot be like higher than the maximum. Okay, so we're just going to say that it's within the restrictions. Okay, so therefore, okay, so we're going to say going to find okay, so the question also wants us to find when it's increasing. Okay, so basically our positive cubic looks something like this. Okay, so and our parabola, okay, should differentiate into something like this. Okay, so then we have our actually it doesn't look something, it looks more like this. So this is our x equals to 1 and this is our x equals to 3. So we have our increasing function here that's increasing so this is increasing when x is less than 1, it's increasing. When x is between 1 and 3, it's decreasing. Okay. And when x is higher than 3, okay, so when x is higher than 3, it is going to be increasing. Okay. Actually, this, yeah. Okay, so we're gonna say increasing, so x is less than 1, it's increasing. When x is between 1 and 3, it is decreasing. And it's increasing when x is greater than 3. Okay, so you need all of these points in order to get the x's. So that's your correct calculation, your correct maximum minimum turning point, and your increasing and decreasing. That'll get you an excellence grade. To get a merit grade, you're finding the correct calculations and one excellence criteria. So either the increasing or the correct maximums will get you a merit grade. To get an achieved, okay, you're finding the R values are correct. Okay, so R equals to 3 and R equals to 1 will get you an achieved. Alright, thank you for watching this video. Okay, I'll be doing the question 3 in the very next video. Okay, thanks for tuning in to this video, and I'll see you in the next one. Thank you.